It is my great pleasure to give the citation for Professor Sachiko Amari for the 2021 H.C. Urey Award of the European Association of Geochemistry. In her more than 30 years at Washington University in St. Louis, she has used the tools of laboratory chemistry, secondary ion mass spectrometry, and noble gas mass spectrometry to make numerous fundamental and important contributions to the field of cosmochemistry, particularly to the discovery, characterization, and interpretation of presolar stardust and meteorites, but also to unraveling the mysterious meteoritic carriers of so-called Q noble gases. Professor Amari's first authored paper, published in Nature in 1985, reported a detailed study of helium isotopes in deep-sea sediments, providing the best evidence at the time that enhanced helium-3 indicated a contribution from interplanetary dust, thus setting the stage for many future studies using helium isotopes as a tracer of the flux of extraterrestrial material on Earth. She arrived at the University of Chicago to work as a postdoc with Professor Ed Anders in 1988. This was immediately after the 1987 discovery by Anders and Ernst Zinner of Washington University that presolar stardust grains, tiny dust grains with isotope compositions indicated they formed in prior generations of stars, survive to this day in primitive meteorites. Because their compositions reflect that of their parent stars, they provide unique insights into stellar processes, and their discovery opened up a whole new field of using geochemical laboratory measurements to probe stellar and interstellar processes. At Chicago, Sachiko prepared acid residues of large samples of the Murchison carbonaceous chondrite and isolated highly purified samples of presolar diamond, silicon carbide, and graphite grains, very well separated into size and density fractions. The importance of these residues to the growth of the study of presolar grains cannot be overstated. Hundreds of papers, a large fraction of them authored or co-authored by Sachiko, have been published since the late 1980s that involve isotope measurements of grains she isolated. Sachiko moved to WashU in St. Louis in 1990 for a research scientist position and has remained there ever since, currently as a research professor of physics. Many of the fundamental discoveries and key papers on presolar silicon carbide and graphite grains since the late 1980s were led by her, including the discovery and characterization of presolar graphite, presolar silicon carbide grains from supernovae, the first trace element measurements of presolar grains, the discovery of presolar grains from novae, and many others. She has continued to produce and contribute to important presolar grain papers to the present day, most recently in a 2020 Nature Astronomy article documenting evidence for presolar silicon carbide grains and the precursor materials of calcium-rich inclusions, the earliest solids known to have formed in the solar system. In addition to her work on presolar grains, Sachiko has never given up on her noble gas roots and has specifically focused a great deal of effort on addressing the still unsolved question of what phase or phases carries the most abundant noble gas component in meteorites, known as phase Q. The Q carrier has been long thought to be carbonaceous, but by carefully combining laboratory chemistry, Raman spectroscopy, noble gas mass spectrometry, and transmission electron microscopy, Professor Amari's research has indicated that Q is most likely associated with nanoparticulate graphene. Presolar grains offer unique insights into how elements are synthesized in stars and how the sun obtained its precise mix of isotopes and elements, a topic that was greatly motivated by the work of and interested Harold Urey. Professor Sachiko Amari's career of making important and fundamental contributions to cosmochemistry, especially to the burgeoning field of presolar grains and meteorites, has greatly helped us better understand the starting materials of our solar system and how they formed. I met Sachiko in 1991 when I arrived as a fresh graduate student at Washington University. My first week, I was handed a stack of papers, half of them authored by Sachiko, to get up to speed on the new science of presolar grains, and a large portion of my PhD thesis and many following works were inspired by and in direct collaboration with her. It is thus a personal honor and privilege to introduce her for the 2021 Urey Award. Congratulations, Sachiko.